Hello, welcome to the Geography Processes and Landforms podcast. It's February 2011. In this episode of the podcast, we're going to be looking at making a climate graph. Climate graph typically displays the mean temperature and mean precipitation by month for a particular location. By examining the temperature and the precipitation data, it can provide a quick and genuine indication of the average climate for that city or region. By displaying the climate statistics as a line and bar graph, it can be much more useful and easier for people to understand. In both cases, the horizontal axis along the bottom of the graph indicates the month, and the vertical axis on the left-hand side indicates temperature in degrees Celsius, while the vertical axis on the right-hand side displays total precipitation in millimeters. The climate graph consists of two parts: a line graph used to represent the mean temperature of the month, and this is generally colored red, as well as a bar graph, which indicates monthly precipitation, and these bars are generally colored blue. Climate graph interpretation can give you some indication of the temperature and precipitation ranges for a particular location, as well as the distribution of that precipitation throughout the year. The patterns of distribution in the climate data may also provide information that can help you determine the continentality of a location, its latitude, as well as which hemisphere it may be located in. Patterns in precipitation may also provide clues about the nature of the flood or drought risk experienced at a location throughout the year. And you may be asking yourself, where can I get my climate data to build a climate graph? Well, you can collect it yourself if your school has a weather station. Secondly, you can go to a government website such as the Weather Office at Environment Canada or the National Weather Service in the United States. There are also a number of other sites on the internet that can provide data for a particular city, region, or country, such as the Weather Network. All of these sites have climate data to help you build your own climate graph. You can go to these sites, copy or download the data for your town or city or a location close to you, and use it to build your graph. Also, many school atlases also contain climate information that may be useful to you. For this exercise, we'll be using information gathered from the Weather Office at Environment Canada, principally for the city of Toronto in Ontario. So let's go there now. Okay, in order to get the data, we're going to need to create our climate graphs. We're going to first navigate to the Weather Office at Environment Canada. So we're going to go to the weatheroffice.gc.ca. We're going to come over to the left-hand menu. We're going to click on Historical Weather. And assuming the internet's fast enough, we will move to a page that looks like this. We're now in the National Climate Data and Information Archive, and there is a huge amount of information here available for climate projects. So for this example, we're going to use information from the climate normals and averages. So we just click on that. That takes us to this page. Now, right now we're going to be searching through cities across Canada that have these long-term normals or long-term averages created for the time between 1971 and 2000. You can do a search by province. So you just click on here, go to your particular province, and you can do a search in there. In our case, we already know what city we're going to be using, so we're just going to type in Toronto, and we're going to hit search. And this is what we end up with. We actually end up with about 8 places across Toronto that are using or collecting information on climate. The one we've chosen to use is the International Airport, Lester B. Pearson International Airport in Toronto. So we'll just click on that. And this is what we get. We get a great deal of information on the long-term average. So we start off here with temperature. We have information on the daily average, maximums, minimums, as well as extreme maximum and minimums, and the year in which they occur. We also have information on precipitation, rainfall, snowfall, average snow depth, extreme daily rainfall events. We also, if we scroll down here a little bit, We have information on days with maximum temperature, minimum temperature, days with snowfall, with rainfall. We also have information on wind speed, wind direction, maximum gusts. If you're interested in gardening or growing season, we have information on the degree days per month, information on humidex values, wind chill, humidity, as well as pressure, visibility, and the amount of cloud at that location per month for these long-term averages. So right now, for this exercise, what we're concerned with, information we're going to be using is the daily average temperature. So that's this first row right here. And what we're going to do is we're going to copy that data and then type it into our table that we'll use to create our climate graph. The other piece of information we need is the total precipitation value down here. This is a combination of the rainfall and the snowfall events. So we want to use this row, and we'll type these values into our table to create our climate graph. Now these are the long-term averages. If you wanted to use perhaps just a single year, say 1985 or 1995, you can actually go back and search through the online data to find that. We're going to use the year 2005 as a second graph and to compare against the long-term averages. Now to find that data, we just go back to the home page, wait for the internet, we go to Climate Data Online, and again we come to another search engine. Again, we can search by province, and then you can go and search by province, or you can simply click on the province in this map at the bottom. You can see the provinces all become highlighted. So we're going to click on Ontario, and in Ontario there are a number of cities where Environment Canada maintains these long-term or online climate information data banks. So you can go in here and select any one of these cities. We're going to select Toronto, and on the right hand side here we're going to go over and select the year 2005. We were going to set the interval to be monthly, so we're getting all the climate data on a monthly basis for that year. And then we'll just go up to here and we'll click go, and you end up with a graph that looks like this. Now this is the climate data for Lester B. Pearson International Airport, which is why we chose that for the long-term normals for Toronto. And we have the months down in the first column here. And again, we're going to be focusing on the mean temperature here. So we're going to use this third column for each. We're going to copy this data out and put that into our table we're going to be using to create our climate graph. And the next column we're going to be looking at is the total precipitation. Again, this is a combination of the rainfall and the snowfall events. So we have an example here in January. We have a total of 70.4 total millimeters of precipitation in January. So once we copy that data over to our graph, then we're good to go. Okay, let's get started building our climate graph. We're going to be using a computer to do this today, but this can easily be done using colored pencils, a ruler, and some paper. For this exercise, we'll be using the numbers spreadsheet program that comes installed on a Mac computer, but you can easily build a climate graph using Microsoft Excel, and there's several examples that are downloadable from the internet that will take you through the tutorial. Just a note, remember to save your file several times as we work through this exercise. Now we'll start with what we see here, basic spreadsheet program, opening template, very familiar for a variety of spreadsheet programs. We have columns running across the top. We have rows running down the left-hand side, and each one of these little rectangles is known as a cell. Now by clicking on the graph, you can see we have kind of activated it. If we go down to the lower right corner, you can see that we can drag it around to add columns and rows to our spreadsheet. If we go and add some data to it, we add a bunch of cities here. If we highlight those cities, we can change font style make it bold, maybe make it a little larger to size 14 font, and then change the actual font to something that you think looks more appealing. If we have a set of numbers, such as 1 and 2 here, if we highlight both of them, grab the lower corner, the computer will then proceed to fill in the remaining squares as we count down by dragging this. It will also do the same thing if we click on January. If we type in January, the computer will automatically fill in the remaining months of the year. Now, our basic spreadsheet layout for this exercise will look something like this. We will have the 12 months of the year going down the left-hand side in our second column, and then temperature and precipitation in the following two columns. Temperature will be measured in degrees Celsius, precipitation in millimeters. We then return back to the climate data we retrieved from Environment Canada for the City of Toronto, and we type in that data into these columns to get something that looks like this. We have minus 6.3 degrees Celsius in January with about 52 millimeters of precipitation. Just to note that you can see I've entered the columns or the data vertically. You can also enter it horizontally and we'll get the exact same results in creating the graph. So if we move to just looking at the vertical columns, if we want to create our graph, we'll take our cursor, highlight the data that we want to use in the graph. We click up here in the top left column, hold the mouse button down and drag across our data. We then go up to top of the chart here. We pick up charts and we want to scroll down until we get to this one. So we have basically two graphs here. We have a line graph and a bar graph and two axes. So if we click on that, the program will take the data we've input and go through to very quickly create our climate graph.